Okay, applications of trigonometry. First part A, is angle of elevation. So what do we call angle of elevation? Let's have a look. So the angle of elevation can be used to measure the height of tall objects that cannot be measured directly, like a building and tall trees and things like that. Now, important part here to remember is the elevation goes from the ground, the flat surface, to the top. Okay, and also the angle of elevation, angle of depression is both using the right angle triangle. So when you think about right angle triangle, you really need to think about Sohcahtoa. Okay, all right, so that's the elevation. What about depression? Let's have a look. Okay, so depression is the angle of depression is the angle formed when looking down from a high place to an object below. So that's high place there, maybe on top of the building, and the object's down here looking down. Now again, the depression is from the flat sort of surface or sky down. Okay, so elevation, it was the ground to the ray, and whereas the depression is the flat from the top to the ray. Okay, now both of them again using the right angle triangle. Now as you can see, the top and the bottom is the parallel to each other, and we can actually see this is alternate angles in parallel lines, and therefore they're equal. Okay, now I always found it's easier, doesn't really matter what kind of question you get, as long as you get like a depression elevation. First thing you've got to do is draw a right angle triangle. Okay, how complicated the story might be, just draw a right angle triangle and then put all the information you can get from the question and then solve it. Now using the Sohcahtoa, because it's a right angle triangle. If it's not right angle triangle, you cannot use Sohcahtoa, obviously. Okay, let's have a look at the example. Let's have a look. See if you can see this one. Yep. So find the angle of elevation. Okay, so that's elevation. So it's going up, isn't it? From the flat ground to the up of a 15.9 meter cliff from a point 100 meters out from its base. So if I can sort of sketch this, I'm going to just draw right angle triangle right there. Okay, just do it. And then it says elevation. So obviously from the ground, this is the ground, to the up, that's elevation. And it says cliff. So this is cliff here, the height. So I'm going to put 15.9 there. And it says cliff is that, and from a point 100 meters out from its base. So cliff is here, the base is here, out from there, and the point is here, and that's 100 meters. Okay, so if I draw nicely, it'll look like this. So push this one up a bit. So, and I just sketch the right angle triangle, and like what I did before, elevation, there's a point there, and that's a base, that's a cliff, 15.5 meters tall, and it's 100 meters away from the base to the point. Now we need to find, what was the question? Find the angle of elevation, which is the theta, and I need to think about this. So opposite to the angle is opposite, so I'm going to just put opposite there. And we don't have hypotenuse, so I'm not going to use hypotenuse, but I have information about PB, which is 100 meters, which is the adjacent, because it's got two angles on one line. Okay, so I've got O and A. Which one has O and A? Of course, tan. So if I did that, now just remember, if we want to look for angle, we got to use shift trig ratio, one of them. So we picked 10, so we're going to do tan theta equals opposite over adjacent. So if I push it down a little bit, I can see it, opposite over adjacent, so 15.9 over 100. And if I move the tan to the other side, it's the inverse. So if I do shift to tan, I will get a decimal, but don't panic. To get the degrees and minutes, you just press this DMS button and you will get 9 degrees and 2 minutes to the nearest minute. Okay, so that's done. All right, so let's have a look at the second example. Just cover the solution so you don't jump into the conclusion there. Okay, so let's have a look. Example 2. The angle of depression, now again, so that's depression. What's that one, depression? It's coming from top to bottom, yeah? So I'm just going to sketch something. Then, so that is the depression, okay? So from the top of 50-meter tree, so that's my tree, okay? And down to a pond is 25 degrees and 41 minutes. If a bird is perched in the top of the tree, how far does it need to fly to reach the pond to the nearest meter? So what does that mean? Like, it's got too many words in there, so you're already lost halfway through. I can see that. But just remember, right angle triangle, okay? And then, because it's a depression, it's going to go down from here. That is 25 degrees and 41 minutes. But also that this is the same because it's what? Alternate, isn't it? So 25, 41. And how tall is a tree? 15. And then, so that's the bird's nest there, and that's the pond, that's the tree, okay? Now, what are we actually looking for? It says here, if a bird is perched in the top of the tree, how far does it need to fly to reach the pond? So bird's here, and how far is the distance, okay? Distance. So this is the distance. How far does bird have to fly to get to the pond? Okay, so I'm going to call that X. And if I sketch it nicely, it'll look like this. Okay, so again, the 3 steps: sketch the right angle triangle, and then put all the information. And I'm going to put X is the one that I'm looking for, which is looking for the highlighter. This is the distance we're looking for. Okay, so let's have a look at the Sohcahtoa. What I've got here, I've got opposite and angle. Okay, so that's okay. We can actually do that. Let's have a look. Opposite. So what have we got here? So what's this one? Oh, forgot. That was a hypotenuse. Yes, X is hypotenuse. Okay, so we got O and H. O and H, obviously, that's a sine. So I'm going to put sine 25 degrees and 41 minutes equals opposite over hypotenuse, 15 over X. And I'm just going to have to swap this around, and I will get something like that. But the question says to the nearest meter, so it'll be 35 meters. Okay, so next one. Now, don't stress out for the next question because it's going to be yes, I can see already a lot of you stressed out or switched off when you look at these, but it's not that bad. Let's have a look. Builder Joe stands 4.5 meters out from the foot of a building, and it looks up to the top of the building where the angle of elevation is 71 degrees. And the builder Ben stands at the top of the building looking down at his wheelbarrow. And that is 10.8 meters out from the foot of the building on the opposite side from where Joe is standing. Now, important part is there's two builders, but it's only one building. Okay, so again, don't panic. Part A, find the height of the building. Okay, we'll stick with the right angle triangle. So I'm just drawing right angle triangle. Let's see. Okay, so this is the building, okay, obviously, and let's say that's Joe, and elevation of the building is 71 degrees. All right, that's not too bad. And then it says here, Joe stands 4.5 meters out from the foot, so 4.5 meters, okay, from the base to there. Okay, we saw the, one of the builders out. Let's have a look at the second builder. Now, Ben is on top of the building. So, Ben is on the top, looking down at his wheelbarrow. So, we don't know where the wheelbarrow might be. So, some here. But important part is it says here, opposite side from where Joe is standing. Joe here. So, opposite, Joe is standing here. Wheelbarrow will be here. W. So then I'm going to match up here like that. And this part is what? 10.8 meters. Because it says here 10.8 meters out from the foot of the building to the wheelbarrow. Okay, so I think we got everything we need. Okay, let's have a look at the slightly better version of the diagram. Okay, so this is what I've got. Okay, I think it's a pretty much same as what I roughly sketched. Now, part A, find the height of the building. So that's the height. Okay, so when I look at this, I don't really have to look at the whole thing, but I can just look at this triangle, right? That one. I can use this triangle with a Sohcahtoa. So don't worry about this part. I'm just going to focus on that. So in triangle ABJ, we're going to use Sohcahtoa. So let's label them. You always have to label them. So H we're looking for, the opposite, so it's opposite. And the information we got is the AJ, which is adjacent. So O and A, 10. So here it is. 1071 equals opposite over adjacent. Opposite of adjacent, so H of 4.5 and H equals, you times it together, and it's going to be 13.1 meters. I just picked the 1 decimal because the other information was in a 1 decimal place, so I just made it into 1 decimal. But it's always nice to indicate what you've done. So in the brackets, 1 decimal place. Okay, so that was part A. Let's have a look at part B. So I just re-sketched this one. Now, part B was trying to find the angle. Okay, let me see the question. It says, find the angle of depression from Ben down to his wheelbarrow. So, depression, well, it was meant to be like this, but which is the same as that. So if we can find the theta, that's the angle of depression. Okay, so we sketch the all the diagram first and the Sohcahtoa. So we are looking at the big triangle now. Okay, so I sketch this here again. All right, so because we know what height of the building is, was the previous question, was the 13.1, that, and let's label it. So that's opposite and that's adjacent. So which one has the O and A? O and A, 10. And again, if you want to find the angle, what do we have to do? Shift trig ratio. This time is tangent. Okay, so that's what you're going to get to the nearest minute. Okay, so make sure you use shift tan for anything to find the angle, or shift sine or shift cos.